Yeah, so this is attempt number 2 to make this video. I started my last attempt here, and my son had sent me a text message and telling me I had to go pick him up. So anyway, I wanted to do a video, and I'm sorry the noise you're probably hearing in the background. We are in a metal building right now. I mean, not that you can really tell that from inside. And it's raining, so you're going to hear a little bit of noise. Anyway, I wanted to do a video about my plans for, well, one, I wanted to talk about some tuning on my car here, and then my plans for some nitrous oxide. I had my friend Evan made a post or a comment on one of my other videos picking on me about nitrous. So, yeah, I told him there would be a video coming, so here it is. Those of you, if you haven't watched any of my other videos, you might want to do that before watching this one if you're interested. But in case you're like me and you're lazy and you don't want to, I'll give you a rundown on what this is. This is my 1984 Corvette. It's got a pile of work done to it. I have a built LQ9, ported heads, fast LSXR intake, Summit Stage 2 cam, Nick Williams throttle body, LS3 water pump, blah, 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 blah. Trunnion upgrades and all that. It's just a junkyard block I pulled out of a Cadillac Escalade. The heads I pulled off of a, I don't know, like an 07 shitbox Silverado. Ported them myself, opened up the valve throats and all that myself. That engine replaced this engine in the bag, which is an LS6 with a cam. Not like a real LS6, it's like a redneck LS6, so it's an LS1 block with 243 heads that I pulled out of the junkyard, and it already had an LS6 intake on it and a bigger cam and all that. But anyway, that'll be going in something down the road. Anyway, and this car also has a 4L80E transmission in it. Dana 44 rear end with 373 gears. Okay, now you're all caught up to speed. When I built this motor, well, let's talk about some tuning stuff that I had go on here first. When I built this motor, I had every intention on, and I built it for nitrous. What I mean by built it for nitrous, it's still the factory flat top pistons, but I gapped them. I put new Hastings rings in, and I gapped them for nitrous. I got a light blinking. Then, if you look right down here, so you probably can't tell, but this right here is my fuel pressure regulator. And this guy here, my camera would focus, is my flex fuel sensor, this thing with the brown plug and this little mysterious black box. So I do have a flex fuel sensor on it in hopes to be able to run flex with nitrous. But you can probably tell, if you've ever run flex fuel before, you can probably tell the issue that I might run into right off the bat, being that this here is the 6AN hose I have. Now this is still high pressure because it's before the regulator. It goes into the regulator, comes out of the regulator, and then goes to the flex sensor. So if I run out of fuel, like if I max out my fuel pump, I may aerate the fuel and start getting inconsistent flex numbers. So what I might have to do, and I just didn't think of it when I put it together, to be honest with you, I might have to switch and make it so that return line goes to the flex sensor before it goes to the regulator, which, being that they're just mounted down there, it wouldn't be that big of a deal. I'd have to cut the tabs off I welded and switch some stuff around, but it wouldn't be the end of the world. I just don't want to. I just don't want to. The flex sensor is wired in. This is all run by a Holley Terminator X Max. It is wired to the Holley. There's a resistor in the harness there. You're not going to be able to see it. I 3D printed a enclosure for the resistor and a little mount that flex fuel sensor sits on. And that's feeding data to the Holley. Now, if you're working on one of these at home and you're not using a Holley, if you're using like a factory 411 PCM or something like that, you may not have to solder in the resistor like I did. I just know that that's a Holley thing, and there's directions right on the Holley forums that talk about extensively how to do it. So if you're running a Holley EFI and you want to run a flex fuel sensor, it's right in the drop-down menu. You can choose it on the software. But when you actually take that GM sensor, like the normal GM sensor, that Continental sensor they call it, that everybody uses, you've got to solder a resistor in so it gets the proper signal. Otherwise, it will burn up the sensor. It won't hurt the ECU, but you can destroy the sensor if you don't put the resistor in there, supposedly. So anyway, I want to talk about a little bit about tuning. And I'm going to try this. This is my crappy garage laptop that I use to tune everything. I don't know how much you're going to be able to see here. Oops, you caught me. I play Raid Shadow Legends on my computer because I'm a nerd. Yep. You caught me. And I can't minimize that for some reason because my computer sucks. Oh, are you kidding me? Yep. Well, that's not going to work, huh? Yeah, that's completely locked up. I can't do a damn thing with this computer other than scroll up and down. Well, that's kind of boring. Huh. Oh, well. I was going to get in there and show you some stuff that I did in the tune, but it doesn't really matter. I can explain it. So when I first got this engine together and got it fired up, if you remember from my last video, I posted a couple videos where I posted a video where I had some trouble with the belt slipping off. That was fixed. My alternator bracket here needed spaced back in a little bit. I got that taken care of. Now the belt stays put right where it should. I was also having some idle issues. It wouldn't stay idling. It would stay idling, but as soon as you revved it and took your foot off of it, it would die. I was doing that without an IAC. And the reason I wasn't using an IAC is because I had a really bad experience with that motor, the LS6 that's in the bag. I ran it with an IAC, and I was sitting at traffic at the intersection in Clarion, Pennsylvania, and I was just sitting at the stoplight, and all of a sudden, my RPM went up to about 3 grand. And I looked, my IAC percentage was pegged at 100%. Now, I had gone through the proper procedure to set up the IAC, and it ran great in my garage, no issue. I drove it 2 or 3 days, no problem, and then all of a sudden, the IAC lost its mind, and it opened up all the way. So I pull over. It tried shoving me through the traffic light. I had to, with both feet on the brake, with everything I got it pulled over, shut it off, started it back up again, and the RPM jumped right back up. That IAC opened all the way, and it went to 3 grand. So what I ended up doing is I had a little Torx set with me. I took that IAC out, extended it out all the way, and then shoved it in the hole just to plug it off, and then I left it unplugged. And that was enough. I could give it, then it would stall, then it wouldn't run at all. But I could give it enough throttle with just my foot to keep it running, and I limped it home. And I called Holly right away, and we went through a whole bunch of stuff. They sent me a new ECU. They sent me an IAC, and actually the IAC that's in there right now is the one that Holly sent me. They sent me everything shy of a new harness, and the problem would not go away. We absolutely never figured it out. So I gave up on the IAC. They sent me a billet block off to plug the IAC hole. So I used that, and then I set my idle with timing, and then I set my idle with the set screw on the side of the throttle body, and I got it to idle at about 910, 920, somewhere in there, and it was okay. A little high, but it was all right. And I drove it the rest of that summer with no major issues. Well, I put this motor in. Now the motor that I got to run with the block-off plate used an LS6 intake and a 78mm throttle body. This, much bigger throttle body, way higher compression, way bigger camshaft. Everything with this motor is bigger. And that 102mm throttle body. Now at first, I don't have it sitting here, I had a crappy Chinese eBay 102mm throttle body on it. Fired up, wouldn't stay running if you revved it at all. No matter where I set, I'd have to set it at 1200 RPM for it to stay running, and that wasn't going to happen. So I swapped out the throttle body for a Nick Williams, thinking, you know what? A lot of people have problems with those crappy eBay throttle bodies. So before I spend a whole bunch of time on tuning or trying to figure out why mine's doing this, let's get a good throttle body on there. And it did help, but it wasn't the solution. The solution was Holly in their base. I used a base configuration to get this running, and this is what I was going to show you on my computer, but my laptop's being a douche. So Holly used a base calibration in their base cals to get you running, right? Now that base calibration worked real well for this motor. No real problem at all, other than it ran rich as could possibly be. I'm going to restart this. It ran as rich as you can imagine and still function whenever you first fired it up. I mean, just absurdly rich. And even when you're driving down the road, it was rich. And I had it in learn mode, and eventually it did get better. But the car always ran rich. There was never, if it sat here and idled, it would foul out spark plugs. And I wasn't good enough with tuning at that time to do much about it, other than just my logic was, well, drive the car more and the self-learn will fix it. The self-learn will fix it. The self-learn will fix it. And it did get better. And it was fast. I was very happy with it, but it still was rich at idle. So I get some advice from some people with this motor. I got some advice from some people at the Holly forums, also LS1 Tech, and some other forums I get on. And I looked, the target air fuel ratio of this thing at idle was 13.8, which is ridiculously rich. So I set that to 14 even, which is still rich. I'm sorry, I'm trying to get my computer restarted here. I set it to 14 even, and then I significantly upped the timing, because the timing in the idle area on the default map that they give you was like 13 degrees. Well, 13 degrees at warm idle is not a lot in a naturally aspirated motor like this. It wasn't happy. Okay, I finally got this thing to open here. Let me try to remember. I think it's that one. Okay, so let's see what we can see here. This is the file that I ended up settling with. This is where I ended up going and trying to get it to run. And no, what is that? 60 idle timing. Okay, no, this is not the right file. I'm sorry. I had the wrong file. And you guys are probably going to laugh at me here, because I am horrible with navigating this software and trying to find anything that I need. Let's try that guy. I can always fire up the car and pull up. Yeah, that's a bit better. Okay, so you can see this is my timing table. Okay, now I've edited it since then. This isn't the one that's actually in the car, but it's close. I've got this is kind of high up in this area that I'm not real crazy about. But here's what I did, and you can actually see it better if you put it on a graph like this, and I move it around. So here's what I did to try and get the idle better. You can see this weird lip right here, like a trough. The reason I bumped the timing up in this row is if the engine starts to die, it hits that wall. And that keeps it running. That's the idea anyway. But the actual idle, normally, just as it sits in idles, would be right here in the bottom of this kind of trough, right? So I come over here and you can see, yeah, this is definitely an old one. I got it at 20 degrees. I've backed it off to like 18 now, but I upped it to 20 degrees from 13 at warm idle. And then at wide open, it was up to 24, which is up here. So I have 24 degrees at wide open up here. At cruise, I got it about 36. That'd be in this area right about here-ish. So this is not what's actually in the car right now. This was just me kind of goofing around, trying to get something that would work better. But once I did this, and then if we go to fuel, and I go to, oh yeah, this definitely is not... This is a good, I want to show you this though. This is not the fuel map I'm using. This is not the right bin file either, but that's okay. You go to target air fuel ratio. Yeah, this is the old one. See, look at this. 13.8. This is idle. It wants to idle at a 13.8, cruise at a 14, and then wide open at 12.1. That's all pretty rich. So I evened this whole thing out to 14, and I don't know what I did with that file. I know it's buried in here somewhere, but I'm not going to bore you. Once I put this at 14 and I bumped that timing up, she idles like a dream. I did have to go through and set just a couple little things. Wow, yeah, these IAC settings are all jacked up. You can see what I was doing. I was trying to get it to idle. It will zoom in. I've got a hold IAC position of 85%. That should be 40. Ramp decay, that should be 4 seconds, not 7. So I was doing some crazy stuff. And the problem with this is a really good example. 85% IAC hold percentage with a RPM above idle to start ramp at 1,000. That actually creates an impossible scenario for the ECU. Basically, what I did whenever I put this in, I didn't even realize it. You'd rev it up and the RPM wouldn't come down. And that's because at 85% IAC, it's above 1,000 RPM. So it'll just stay revved at 15 or 2 grand when you rev it, and it would just sit there forever until you shut it off and start it back up again. This warning is even in the Holley directions. I just didn't pay attention. And no, this was not the problem I had with the old motor. I did find out what that was. That was an old firmware. Holley finally contacted me through email and let me know the original firmware that came with these, the original first release of the Terminator X Max, had some issues where they had some IAC control issues and things like that. I updated to the new firmware, and now I'm using the V2 software, and that problem has gone away. The IAC has not lost its mind. It did exactly, in this case, when it was screwed up, it did exactly what I told it to do, which was to screw up, basically. I just didn't realize it. So, fuel, this was, okay, so let me explain what this is. I used the base cal fuel map, and I put it in self-learn mode, and look what happened. It just pulled this massive amount of fuel out, and that's this dip you can see here. That's just idle and slightly off idle, just me sitting there revving it in my garage, and you can see how much fuel it pulled. So this is a stupid rich fuel map, okay? So what I did is I ended up taking, if you're familiar with the Sloppy Mechanics YouTube channel, I went and took one of the Sloppy Mechanics, might be this one. No, it probably isn't actually. Timing, pump gas, sloppy fuel, that's it. I took the Sloppy Mechanics fuel map that he had off of his tune cabinet. Yeah, this is the newest one I'm running. So Sloppy Mechanics is, if you're not familiar, he's a YouTuber that does in Allentown, Pennsylvania. He does a bunch of tuning using Holley EFI. He has a ton of tune files on a tune tool cabinet that he calls it, that you can go in and copy and download and play with and fiddle with and whatever. He had a tune file on there for a 6-liter LS that said that it had run out of fuel, had too small of injectors in it, run out of fuel. It made like 280 horse on pump gas. So what I did, being that right for now anyway, this is pump gas, I don't have E85 in it yet, I copied his fuel map and I added 10% to the whole map. Then I went through and redid my spark table. Yeah, this is the spark table I'm using. You can see here, this is the idle area. It's not going to focus. Focus. Anyway, you can't see it, but these darker squares, that's 19 degrees. That's right where it's idling at. And then this is that wall. I have 28 and 24 degrees in these 3 rows. That way, if it starts to die, it catches it and pulls it right back over. But you can see I've got this area in cruise way lower. So this is what's in the car right now. Still at wide open throttle, 23, 24 degrees timing is all. So still a little conservative, but that's okay. Anyway, if I flip back to fuel, you can see that it's not quite that Grand Cavern, that cavernous looking dent. It's a little rocky, but it's not bad. So I took his fuel map, added 10% to the whole thing, ran it in self-learn, and this is what it did. It just pulled and added in tiny little spots instead of that huge dip in the middle. So that's kind of my first step. I need to get, before I can put nitrous on the car, I got to get a fuel map in that runs well, and I had to get it idling right, and both of those seem to be pretty good. Unfortunately for me, I can't drive the car yet because it's still raining and ice and garbage Pennsylvania weather. Okay, So, question has been asked, fine. You get this going on a good tune, what are you going to do for nitrous? Because that seems to be what everybody's asking. Well, I haven't gone through and done it yet, but I'm going to go through the advanced tables here, and I'm going to set up a flex fuel so it can actually adjust fuel flow rate and timing and target air fuel based on flex fuel percentage. I need to get that kind of dialed in because I'm going to set the Holley output, being that I'm going to be running a progressive dry shot. And if you're not familiar with what that is, basically the computer pulses the nitrous solenoid at a given rate to raise the nitrous over the course of RPM. So I'm going to jet it for up to a 200 shot. But when you put it in progressive mode, it'll start spraying, let's say roughly anyway, 100 shot. And then as the RPM increases, it'll increase the nitrous flow. The big advantage to this really is twofold. One is traction, and two, it saves on wear and tear of things like the transmission and other parts. It doesn't have quite that sudden shock that a full 200 shot would offer. So this just kind of helps save on mechanical failure. At least that's the hope. That's why I think most people end up looking at a progressive nitrous system. So I'm going to go dry, which means my nitrous system will not add any additional fuel. I'm just going to let the motor blow up. No. What I did, these fuel injectors are way oversized. These are Holley 76-pound Terminator X injectors. They're brand new. Holley just came out with them. In the new firmware on the Terminator X, it actually, once I put the new firmware in, those injectors are now on the drop-down menu. You do not have to enter in any data for them. The fuel pump that's in the tank, and you can't see the pump from back here, but you can see the top of my sending unit and stuff. The fuel pump is right there. That's got a Walbro 450 in it. So I should have enough fuel for 700 horse. That's my goal on flex. You know, somewhere in that ballpark, around 700 horsepower on that pump and those injectors, and I shouldn't be at 100% duty cycle on those injectors at 60 PSI anyway. At least that's my hope. Baby steps, I'm going to take it, start jetting smaller than a 200 and work my way up. I'm going to watch data logs, see what's happening with the NOx sensors, and watch what's happening on my wideband O2 as I run it. And in case you're wondering, and if you're familiar with Holley, no, the NOx sensors do not come pre-configured. I did have to find, if you go on Holley Tech forums, there's a walkthrough there on how to use LS NOx sensors with the Holley Terminator X. So I do have that configured. It's in there. I don't have the NOx sensors pulling timing. I simply have them showing me if there's any, what the NOx percentage is. Okay, so all that said, how in the world am I going to put nitrous in the car? You're probably assuming, oh, he's just going to slam an LS plate system on there and be done with it. Yeah, no, that's dumb. I'm not going to do that. If you're running an LS plate, that's fine. Good for you. That's not what I want. And the reason I don't, it's not because it's not cool enough or something like that. If you have a carburetor and you're running a plate, that's the way to go, man. Especially if you've got like a Holley square bore or something. It doesn't matter what your flange in your carburetor is. If you've got a normal carburetor style intake, and oh man, I got a phone call. Man, I tell you, it's one distraction or the next. I'm going to hurry up and wrap this up because I'm sure it'll be like 9 other people calling me. Like I was saying, if you've got a carburetor intake on an LS or any motor and you put a plate on it, it's awesome because you've got that plate sitting right in the middle of the engine and you get an even distribution of nitrous, roughly speaking, to all 80 of your cylinders. And they work great. Honestly, those plate systems on a carburetor in that way work really just as well as a direct port system, other than they can't flow quite as much in some cases. And of course, there's bigger plates that, of course, can get you as much flow as you want. But when you look at a plate system on an LS motor or anything that uses a manifold like this, where the throttle body is at one end, now when nitrous goes in, it hits these front cylinders and they get more nitrous than the back cylinders do. And I know it sounds silly, and some of you are saying, well, I've run a 150 shot or a 9 million shot on my plate system for years. Yeah, I don't care. When I used to run, I've had nitrous on this car before. I had a tune port motor in here. I mean, obviously, this is a Crossfire Corvette. You can actually see Crossfire injection. So I did have a Crossfire motor in here, obviously, originally, and then I swapped it out for an L98 tune port. I've had just about everything under the sun in here. And every time I've run nitrous on that tune port, especially because it's a similar, if you want to consider it that, to the intake on an LS, similar in that it's through style like this, those front cylinders, the spark plugs would always have a different appearance to them than the back spark plugs every time. So those front spark plugs were taking more nitrous. They were running hotter. And that's just a fact of life. And I don't want to deal with it. So what I'm going to do, and that's why I bought the fast intake manifold, because it has these guys. It has bosses in it for direct port nitrous. So my plan is I'm going to drill and tap those bosses and put in direct port nitrous nozzles. Now, you might be asking, oh, so you're just going to send it to a machine shop and spend lots of money? Hell no. No, that's why I have a 3D printer. And I made these. These are jigs that I designed and made myself that allow me to drill straight holes into a fast intake manifold. So I have two. I have one that has this protruding nipple here in the end, and it has a 1/8 inch hole through the center of it. This is just done in eSun PLA Plus. I think it's maybe 40% infill or so. But if you look at it, she sits right down into that bung, nice, snug, tight, and it will easily hold straight for an 1/8 inch pilot drill bit. Then I have a second one that has a taper on the end of it. I don't know if you can see that or not. Has a taper there on the end of it that matches the contour of that taper of the nitrous bung perfectly. So once the pilot's drilled, you hold this in there. This hole is the same size as a letter gauge D drill bit, which, oh good, it did not hit the floor. Fantastic. Oh, I lied, it did hit the floor. So letter gauge D, which is this guy right here, is the size that you need as the hole for a 16th NPT pipe tap, which is what this guy here is. 16th NPT is what your average nitrous nozzle uses. So the plan is to drill and tap all those out and thread dry single nozzle dry nozzles in there. Now you may be wondering, Chad, why did you not do that before you bolted the intake on the car? I want to give you a good answer here. I really want to have a good reason why I didn't do that before I bolted it on the car, but I don't have one. I got excited that I bought a fast intake manifold and I threw it on the car and I started it and I ran it and I didn't drill it for nitrous first. I don't know why. I don't have an answer. So yes, this will be coming back off whenever I drill it for nitrous. No, I'm not going to worry about it till after the tune's dialed in. The nice thing is I threw new gaskets on this. The gaskets are reusable. It won't cost me a dime to pull it back off, just a little bit of time. So I'll pull it off, put it on the workbench, drill 8 holes in my $1,100 intake manifold, and then tap them and thread some nozzles in. I'm going to go with a single trash can style solenoid that's going to sit back here. And then the Holley is going to control that for progressive. You do have to get an SSR, a solid state relay, that Holley uses to control that solenoid. Now, as far as where to put it, and I think I had this in the other video, but I'm actually going to cut the video off and turn it back on because I can't move this one-handed. If you see in here, you can't see in there because I need a light. Let's get a light. Let's get a light together. Here is a speaker box I built, and I have some Scar Audio 8s in there, right? They sound really good, by the way. If you're not familiar with Scar Audio, they do sound awesome for the price. They're very budget-minded, but they sound really good. The nice thing is with these back compartments, I can still lift these up, at least far enough to be able to get access to them, or to the compartments, so I didn't completely lose that. But if you're a car stereo aficionado, you may realize, man, that is a big speaker box for 2 Scar 8s. Because the thing about Scar 8s is these aren't the bottom of the barrel Scars, they're like one step up. I can't remember the model number because I'm not that nerdy and I just don't care. but these ones are a very small box volume. And if you're looking at this box from the back, well, that's a pretty good size speaker box. Well, they don't actually need all that speaker box. You can see the seam right here in the box. This is a false lid. This is the speaker box. This is a false lid. So let me cut the video off and I'll pull that lid off so you can see what's inside. Hang on. Okay, so this is, I pulled the lid up and I just set it right here. You can see I got this area back here. This is just my speaker wiring coming out. I have this area for a nitrous bottle. So right there is where my 15-pound nitrous bottle, I have a 10-pound now, but I'm going to be buying a 15, where the 15-pound nitrous bottle will live. I'll probably have an automatic bottle opener and a bottle blanket and a relays for the blanket and all that kind of fun stuff. So I'll have nitrous inside of a speaker box, so to speak, and that's where it'll hide, which I think is kind of cool. And then it'll all be controlled by the Terminator X. So that's the plan anyway. I still got a lot of tuning to do. Now, one thing I do want to talk about real quick that I was going to mention before I got rudely interrupted like 9 times. I don't know if that flex sensor being after the pressure regulator is going to be an issue. I know lots of people do it that way and they run tons and tons of power. And then other people say they've tried it and it caused problems. So what I'm going to do, obviously it'll run pump gas that way just fine, but I'm not going to be running nitrous on pump gas. So I'm going to drive the car. I'm going to be adding flex fuel and I'm going to do some data logs without nitrous at wide open and just test it and see, am I seeing a fluctuation in ethanol percentage under wide open throttle? That'll kind of tell me if I'm starting to have some fuel issues or aerating that fuel. If I do, I can switch it around and I can put the regulator after the sensor, problem solved. I'm just lazy and don't want to unless I have to. So then, assuming everything's okay, and if I don't see those fluctuations, I'm going to put a little nitrous on it, start small, start with 100 shot or whatever, data log it, see what happens. There's guys, you look at Sloppy Mechanics had the 8 for 8 and he was goofing around and put the flex sensor all the way back on the tank at the back of the car and it worked just fine. So, and that had quite a bit more power than what I'm doing and it was under boost. So, I think it'll be okay. But it's one of those things I just don't know for sure. There are a lot of people that have had issues doing exactly what I'm trying to do. So we will see. I don't know. I can't answer any of that. But anyway, that's all I got. I just thought it was cool. I got 3D printed drill jigs that I'll be, whenever I take the intake off and get it ready for nitrous, I'll be drilling it. But I can't do any of that because the weather sucks. It's rainy. It's icy. I had to scrape a pile of ice off my car this morning, or off my work beater this morning. So it'll be a while before I get it out on the street. But thanks, guys.